Continuing on our journey to find easier ways to take the derivative, let's look at the product rule. So here we're asked to determine the derivative of this function here, 2x plus 3 times x squared minus 4. Now, one option to take the derivative of this is just to expand and simplify and then use our power rule. So let's try that first. So f of x just equals 2x cubed minus 8x plus 3x squared minus 12. Okay, can't simplify anymore, so now we can take the derivative. F prime of x is equal to the derivative of 2x cubed, bring that 3 down, multiply it by the 2, so it's 6x, and that exponent becomes 2. Negative 8x will just become negative 8. 3x squared will become 6x, and then the minus 12 will just go away. So there's our derivative. Now notice how really this function is just 2x plus 3 times x squared minus 4. My question for you is, could we take the derivative of this and the derivative of this and just multiply those together in order to get the derivative of the whole thing instead of expanding and simplifying? Is that another option? Because we can sort of do that when we're adding functions together, right? We can just take the derivative of each one individually. Can we do the same thing for multiplying? Well, let's try it. So if this was true, we can take the derivative as f prime of x as the derivative of what's in the first brackets, which is just 2, right? So that's just going to be 2. And then multiply it by the derivative of what's in the second brackets, which just that x squared is the only thing that matters, right? So it's going to come down as 2x. This would be the derivative for x, f prime of x. Is that true? Well, if we zoom out and look at our other answer, clearly it's very different. So the idea is here we actually cannot take the derivative by just multiplying the two parts together. There's another rule called the product rule, and it's actually a little bit more complicated than just multiplying the derivatives together. Okay, so the product rule basically states this. If we want to take the derivative of two functions that are multiplied by each other, f and g, the derivative is f prime of g plus f times g prime. Or another way of thinking about it, based on our Leibniz notation, is if u and v are functions, it's u times the derivative of v plus v times the derivative of u. So let's show how that works with an example. Notice how I changed example 1 to the same as the example from above. I did that just so that we can check our work, because we already calculated the derivative of g of x, right? So we'll use this as our g of x for this equation. And our pattern, if we look in the top right corner, says we need to do f prime g plus fg prime. So if we sort of call this part right here, this first part f, and we call this second part g, really what we're doing to find g prime of x is we've got to find f prime g plus fg prime. So f prime is just the derivative of f, and that's just going to be, if you look at it, it's just going to be 2, right? Because that 2x is the only thing that's going to still be there after we take the derivative, and then we multiply that by g, and g is just x squared minus 4. Should be a 4. And then we're going to add to that f, which f is just 2x plus 3, and g prime. And g prime is just the x squared is the only thing that matters, so it's just going to be 2x. Of course, now we can expand and simplify, so 2x squared minus 8 plus 4x squared plus 6x. And then further simplifying this, the 2x squared and the 4x squared are going to add, so we get 6x squared minus 8 plus 6x. So that is our derivative. That's our g prime of x using the product rule. And if we look up here at what we did when we expanded and simplified and then took the derivative, and we used the product rule, same answer both ways. Okay? So our product rule seems to work, at least in this case. So your question might be, why do we use the product rule at all? Why can't we just expand and simplify? And the answer to that is sometimes it's going to be more complicated to expand and simplify, it's easier just to use the product rule. So let's do the same thing here with this example here. So I'm going to, again, just to identify, just to make it easier for us, I'm going to call this f and I'm going to call this g. So h prime of x is going to be f prime g plus f g prime. Okay? So f prime, we look at that function f, it's going to be 3x squared minus, that 2 comes down to give us 8x, and then times g, which is x to the 5 plus 2x to the 4 minus 5x. And we're going to add to that fg prime. Now, you'll see I'm running out of space. A lot of these questions will sort of happen like this, where we're going to end up with a really long answer, but that's just the nature of this, this thing. So x cubed minus 4x squared, and then we're going to multiply that by g prime. And g, we see, is just x to the 5, so that's going to become 5x to the 4, 5x to the 4, plus, that 4 is going to come down, 8x, and then minus 5 at the end. I'm going to go all the way over here, minus 5. Whew. Okay, so there's the derivative of h of x. Do you need to expand and simplify this? Well, if I ask you to expand and simplify in a question, then you should, but this is a bit ridiculous to expand and simplify. It would take a while, it would take half a page of work to do that. One thing, if I do ask you to find the derivative at a specific point, like at h equals 1 or h equals 2, do you have to expand and simplify in order to find that? And the answer is no, you can just plug in the value for x into there to get it. So this is okay as our answer for this question. Okay, you do not need to expand and simplify unless it specifically says you do. So here we're asked to find the derivative of h of x at x equals 2. What's different about this function h of x? Well, you'll notice it's a function and it's all squared. So how can we deal with this? We're going to learn a few tricks later to deal with this, but now let's just try using our product rule. First thing we could do is rewrite h of x as 4x cubed minus x squared plus 7, and the squared part really just means that's repeated, right? 4x cubed minus x squared plus 7. Okay, so that's really what our h of x is. We can use the product rule on this because it's two functions being multiplied. So let's do that. H prime of x is equal to, and if you remember the pattern, remember it's basically derivative of this times this plus this times the derivative of this. So you don't need to show the pattern each time with the f and the g and stuff like that. You can just go for it. So the derivative of the first part is going to be 12x squared minus 2x times the second part, 4x cubed minus x squared plus 7. And then we're going to do the derivative of the first part times the derivative of the second part. But question, is that going to be any different from what we already have here? It's just going to be in the different order. They're going to be swapped, right? So really we're just going to add to this the same thing, right? So whatever that is, the same thing. So really basically what we're doing is we're just multiplying this. So let me just erase that. Really what we're doing, if my eraser works, is we're just multiplying this by 2, right? Because there's just 2 of those. Now we can plug in, well, what the question asks us for is to find at the slope of the tangent, the derivative at x equals 2. So we can just plug in h prime at 2. Okay? I'm not going to show you all that work, so pause it now and do it yourself if you want, but the answer I believe should come out to 1400. That is the slope of the tangent at h equals 2. So here we have an interesting question. Find the values of where the tangent of f of x is equal to 2. Now f of x it's not just a standard function like the ones we've been dealing with where it's 2 functions multiplied by each other, it's got 3 multiplied by each other. So before we actually just start taking the derivative, let's do a little bit of labeling here to make it a little bit easier to deal with. So I'm actually just going to call this a, b, and c, those 3 functions. So let's think about what it means to take the derivative of f of x using the product rule. So basically we got to multiply one thing by another thing. So what we can do to sort of simplify this, why don't we group those first two things together and say we're basically multiplying this, these two functions, by this, and then apply the product rule. We could do that. So just to sort of look how that's going to look, f prime of x, it's going to equal the derivative of ab, right? So whatever the derivative of ab is, times c, plus ab times the derivative of c, right? It's the same as our, and I'll put brackets here just so we know we're grouping that together. It's the same as our product rule from before. All we've done is we've grouped a and b together. So the question is here for this part, when we have this ab prime, how do we find ab prime? Well, can't we just apply our product rule to a and b here? We can, right? F prime of x equals, instead of ab prime is just equal to a prime b plus a b prime, right? Using our product rule, times c plus a b c prime. So basically we now have a pattern that we can just plug our a, b's, and c's into in order to find the derivative of this sort of complicated function. Of course, the other way to do it is just to expand and simplify and then take the derivative, but this way might actually be a little bit faster because these derivatives are all very easy to do. So let's try it. Let's see what happens. So a prime, we're starting off with a prime, and that is just 1, right? The derivative of a prime is just, or sorry, the derivative of a is just 1. B is 2x plus 5. And then we're going to add to that a times b. So a is x plus 4. The derivative of b is just 2. And then we're going to multiply the whole thing by c. And c is just 2x minus 8. Okay? Give us a little bit more space here. I'm actually just going to continue underneath here just to make it fit nicely on a screen. So AB, and AB is just x plus 4, 2x plus 5, right? That's AB times C prime, and C prime is just 2. All right, that's our derivative. Are we done there? Well, keep in mind the question is asking us to find the value of the tangent where x equals 2, right? Or sorry, where the tangent is equal to 2. So do we have to expand and simplify here? The answer is yes, because we need to find, basically plug in 2 here in order to find where x equals 2, right? Or where, sorry, where the derivative where x equals 2. So I'm going to pause it here. How about you pause it here, and I will do the algebra, because it's just a lot of algebra, and then we'll come back and you can see if you can find the answer. So after a bit of expanding and simplifying, we get that this is our answer, 12x squared plus 20x minus 64, if I didn't make any algebra mistakes. So essentially what we got to do, what the question is asking us for, is to find what values of x will give us a tangent of 2. So remember, f prime of x just stands for the tangent, right? Slope of the tangent. So we basically got to find where this is true. This equation is 2. 2 equals to that. So you can use any method you want to try to solve this. Remember, we've got to move that 2 to the other side. Maybe use the quadratic formula, maybe try to factor it, and see what you get. Pause your video here and I'll give you the answers in a second. So you end up having to use the quadratic formula to solve this equation, and these should be your answers. -5 minus root 223 over 6 and -5 plus root 223 over 6 are the exact answers. So remember, these are the locations where the slope of the tangent is equal to 2.